In this video, we're going to talk about the least squares regression line. This is kind of going to pick up from the previous lesson on scatter plots. So I would like to just mention a couple things that I didn't get to mention about scatter plots from the previous lesson. So you see that if you look at the previous lesson, here's our scatter plot. Here's the line that we drew for the line of best fit. The scatter plot comes from this data. So if you're viewing this video independently of, you're not going to watch the scatter plot video, then just pause it, read the study, plot these points, and you'll come up with the same scatter plot. One of the things I mentioned was about the correlation. The correlation has to do with how all of the dots or all of the plots, the x's, are going in the graph and what the trend is. But it also has to do with how far apart they are. So for instance, in this graph, we can see the line is diagonal. It's going up from left to right. Sometimes you're going to have a scatter plot where the line will go diagonally downwards from left to right. Sometimes you're going to have a scatter plot where all of the x's are kind of in a circle or maybe in a square, some shape. So the two things that you need to know about correlation is it has to do with what the pattern is of the plots, what kind of line they form, if it goes up or if it goes down diagonally, and also how far apart all the dots are. If you have a diagonal line that goes up from left to right, this is going to be a positive correlation. Or if you have a positive value for a correlation, then you know that you're going to have this kind of diagonal line. If your diagonal line is falling, it's going to have a negative correlation. Then the other thing that you're going to analyze about the scatter plot is if the dots are close, then that means your correlation coefficient is going to be close to 1. The closer the dots are to each other, the closer it is to 1, or -1 if it's falling. 0.5's being about in the middle. And then if your dots are pretty far apart or pretty scattered, then that's going to be a number that's going to be between 0 and 0.5. And obviously you can have a -0.5 because a -0.5 would fall from left to right. So two things to remember is the sign is included with the way that the line falls or rises, and close dots includes the way that the number is. If it's close to 1 or if it's not close to 1 and closer to 0, it's going to be scattered. Closer to 1, they're going to be close together. So in this lesson, we're going to talk about the least squares regression line. And you may have seen, if you're reviewing or if you're looking into statistics for the first time, you know this acronym lsrl. That's the least squares regression line. What is the least squares regression line? This is the line that is the best fit, and it's the best line of the best fit. So if that's too many bests, then just understand this. So if I want to draw a line of best fit for this data, maybe I drew this line. Well, maybe I had a different opinion. Maybe I thought the line went like this. Maybe I thought that that was a better line. Maybe someone else in my class thought that this was a better line. No one really knows which one is the best line if you do it by eye. It's kind of a matter of opinion. But there's a way to calculate the best line of best fit, and that's going to be by using a computer or a calculator. And the line that best fits this data, I can't draw, you can't draw, only a computer or a calculator would be able to draw the exact line. And that line would be called the least squares regression line. Okay, now why do we want to use the lsrl? Why are we interested in this? Try to get invested in the study. The study measured the hours spent training versus the maximum leg press at the end of that period. So pretend that you're a researcher and you're trying to draw a conclusion from this study. You might want to say, you might want to say in your hypothesis that the more hours you spend training, the higher your max leg press could be. So if you were going to say that, you would have to end at 9. You have to say 9 hours gives us this certain output. But what if someone trained for 12 hours? What would their estimate be? That's why we want to do the lsrl, because it gives us an estimate that's kind of close to where the trend of the data is going. So the biggest thing to remember about lsrl is it is a prediction. It is an estimator. Okay, now we get to the mathematics of it. How do we find the lsrl? Well, you have to find it using a calculator or a computer. There is a way to do it by hand. It just takes a long time, and if you take an AP exam or any kind of college exam, you'll be able to use a graphing calculator. So there's no point in this lesson in showing you how to do it by hand. The equation for the lsrl is going to be y hat is equal to a plus bx. I hope you're familiar with linear algebra. When you graph a line in algebra, usually you use this equation, y equals mx plus b, where m is the slope and b is the y-intercept. The y-intercept is where the line crosses this y-axis. So we can't really use this equation because m and b are different things in statistics, or m is something different. So instead we're going to just change this equation around to a plus bx. Once again, the number that's in front of the x, that's going to be your slope. The number that doesn't have an x, that's going to be your y-intercept. And then the thing to remember again is that y hat, anytime you have a hat, it means it's an estimator or a predictor. So we have this equation, y hat is equal to a plus bx, where y hat is the estimated response variable. A is going to be where the line crosses the y-axis, or the axis that's on the vertical. And B is going to be the slope. Okay, so if you use a calculator, and you can find out some way to find out how to do the regression in your calculator. All calculators are different. I use an 85. It's going to be a different way to do it than your 83 or 84. So once you do that and you press your function for linear regression, you get this output. So how do we read this output? A is 194.8. B is 16.87. Correlation, that's going to be R is going to be 0.753. So I'm going to use this data to write my equation for my least squares regression line. So we have y hat is equal to A on the calculator, 194.8, plus B on the calculator was 16.87. Just use 16.9 x. Okay, now when you do AP statistics exam, they like you to understand what the equation means. So we're going to say that the predicted max leg press from the study is equal to 194.8 plus 16.9 times the number of hours spent training. Okay, now that's a lot to write there. If you could abbreviate it, that's better. When you take the AP statistics exam or when you take a statistics test, you'll want to define your variables. So either way is fine, just so you make a mention of what y hat means, make a mention of what x means, or you can use words. Okay, so here's our lsrl. And remember, it's an estimator, and I'm going to show you why it's an estimator here. It's an estimator because it still is a line that predicts the position of all of these points. So if I look at my chart for 5, I'm going to have 225. 5 hours training, 225. Notice that that point is not on this line. Once again, this is an estimate of what the position should be. So let's just check it real quick. If I were to do what's the estimated value for 5 hours? You calculate it, 194.8 plus 16.9 times 5. 279.3. So you see how that's not equal to the actual value of 225. Once again, this allows us to predict the amount of pounds on the leg press for a certain number of hours, but it's not exactly correct. You have your actual data to show you what exactly you got. This is an estimator. All right, so we use this as an estimator. Let's pretend that you go back into the study here. We got these 10 women did this study. Let's pretend that someone wasn't there that day, but they had recorded their data. And they recorded 6.5 hours. So we could estimate what their max leg press would be based on 6.5 hours spent training. Okay, once again, it's an estimate. It's not going to be the actual amount that they could do. This is just kind of what our study is showing, what we would predict. Okay, we would predict that someone would be able to leg press 304.7 pounds. If they trained for 6.5 hours.